बिस्मिल्लाहिर्रहमानिर्रहीम रब्बि इश्रह ली सदरी व यस्सिर ली अमरी वहलुल उक़दतम मिन लिसानी यफ़क़हू क़ौली रब्बि ज़िदनी इल्मा. A topic on which I am going to discuss is refraction of light. Refraction of light. Refraction of light means if light rays are traveling in one medium such as air. If light rays are traveling in one medium, such as air, it strikes obliquely the surface of another medium, such as glass. The light change their direction in the second medium, it is in glass. This change in the velocity and direction of light in the second medium is called refraction of light. If light rays are traveling in one medium such as air, it strike obliquely, not straight, obliquely the surface of another medium such as glass. The light change their direction in the second medium. This change in the velocity and direction of light in the second medium is called refraction of light. Is refraction of light. A parallel sided transparent material is called glass slab. This is called glass slab. A parallel sided transparent material is called glass slab. This is called glass slab, and it is drawn in figure is this, like this. This is called glass slab. Let's say P, Q, R, and S. P, Q, R, and S is a glass slab. OC is called the incident ray. This is called the incident ray. It's called incident ray. OC. Or let's say this is O and this is C. OC is called incident ray. This is called incident ray. CO is called incident ray. This is called incident ray. Is the direction in which the light falls on a glass slab, O is the point of incident. O is called the point of incident. Let's say this is called incident ray, and this O point is called point of incident. O is the point of incident, and OE is the refracted ray, and OE is the refracted ray. The original direction of the light is like this, but in the second medium it changed their direction, so this is called OD and this is OE. OE is called refracted ray. OE is called the refracted ray. The angle I and R which incident and refracted rays makes, and this line perpendicular to this slab is called normal. NON dash. This angle is called angle of incidence, and this is called angle of refraction. Here in practical diagram, this is called the incident ray, this is called the emergent ray, and when ray of light enters from this rare medium to a denser medium, it changes their direction. This change in the direction and velocity of light in the second medium is called refraction of light. Refraction of light. The angle incidence I and R, which incidence this can also be represented by theta I and theta R. Theta I and theta R, which the incident and reflected rays with makes with in on and O and dash the normal are perpendicular at the point of incident are called the angle of incident and reflection respectively. The angle of incident and reflection respectively. So this is called incident ray. The ray of light approaching, the boundary of reflecting surface between the two media. The ray of light moving away from the boundary between the two media is called a refracted ray. This ray is called refracted ray. Normal. The line drawn perpendicular. The line drawn at right angles to the reflecting surface. It's called normal, and the angle between the incident ray and the normal is called angle of incident theta I, and the angle of refraction, the angle of refraction is the angle between the reflected ray and the normal. The angle between the reflected ray and the normal are in figure. This is a glass slab, rectangular glass slab. This is called incident ray. This is called incident ray, and this is the original direction of the light, and this light changes its direction, so this is called a reflected ray. And this lines drawn perpendicular to this line is called normal. So the angle that makes with incident ray with the normal is called angle of incident theta I, and this is called angle of refraction. Now there are some laws of refraction. There are two laws of refraction. Laws of refraction of light. 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 Number one. The incident ray, the reflected ray, and the normal at the point of incident all lie in this plane board, this white board. So the angle of incidence, the two laws of refraction are the incident ray, the incident ray, the reflected ray, and normal at the point of incidence. At the point of incidence, all lie in same plane. This is the plane of paper or whiteboard. This plane or this in whiteboard. So the incident ray, the reflected ray, and the normal all lie in the same plane. The second law is the ratio of sine of angle of incidence. The ratio of sine of angle of incidence to the sine angle of reflection is constant for given pair of media. And it is represented by N, and is called refractive index. The refractive index is the ratio of the refractive index is the ratio of sine angle of incidence to the sine of angle of reflection, or in other words, The refractive index is the speed of light and air to the velocity of light, or the speed of light and air to the velocity of light in the particular medium V. So the refractive index is the ratio of the velocities of the light, the velocity of the light and air at are vacuum to the velocity of light in a given medium. In air, it is denoted by n, and is equal to c divided by v, and it is the ratio of two similar physical quantities. So it has no unit. So it has no unit. It has no unit. Refractive index has no entire. The refractive index of a substance doesn't depend on the angle of incidence, but depends on the nature of the material, medium, and the wavelength of the incident light used, and the wavelength of the incident light used, and the wavelength of this is also called, this second law is also known as Snell's law. Snell's law. Snell's law. And Snell's law is stated as follow. Snell's law. Snell's law. This law states that this Snell's law, which is stated that the product of the index of the refraction, the products of the index of the refraction of the first medium and the sine of the angle of incidence is equal to the product of the index of the refraction, the second medium, and the sine angle of incident, That is n1 mathematically. L1 sine theta 1 is equal to n2 sine theta 2. N2 sine theta 2. Here n1 is the less optically dense medium, it is air, and n2 is the greater optically dense medium, that is n2. Thanks.